what he introduced, I don't know. But yeah, my name is Edwin Adriaanse with TomTom. And a few months actually ago, they asked me to speak in this conference. Need some time to wake up.
Yeah, you have 5 minutes to prepare.
It's worked great, but let me just check. It's not recognizing the screen. It did perfectly when we prepared this, but
This is standard demo effect.
so let's hope it will pick up. Not, then I will start it again. This better. Okay. So they asked me a couple of months ago to do a presentation in mobilization, and to be honest, I didn't hear of mobilization before. I went to Łódź a few years, but I never heard about mobilization. And they warned me like it's a funny conference. I said, what's funny about? Well, first of all, they said it's a Saturday. I thought, well, it's normally a day off. Very interesting to see you all here. Secondly, you have to wear a uniform. I thought, that's a bit strange, but hey, you know, I joined the army like 22 years ago. I thought, well, I have to dig in my stuff, my old stuff to find something, and surprisingly, it still fits. I mean, I have to, but it fits. So, 22 years ago, I joined the army in central Bosnia, as you can see with this picture, where we did provide food. We provided food for people that the Red Cross and other civil organizations didn't go to anymore. It was too dangerous, and therefore we used those vehicles. And this was what we called the commander car, where I was in. And funny enough, you can recognize it easily because it's different from the trucks. So I think if there was a sniper in the neighborhood, they know where to aim for. But it was also my first experience with GPS, not knowing that I would work 20 years later for TomTom. At that time, GPS was a big box in the middle of that car with a display in front of you, putting the GPS coordinates. And you had a map, and you could actually exactly know where you are. And at that time, this was great. In case you were lost, you still could know where to go to. So, why are we here? Well, that's a question for you, I know. First of all, I want to talk about dedicated devices. What are dedicated devices and what is the difference with them? I also want to discuss the agile way of working. How does that work when you develop software for dedicated devices? Does it agile fit doing so? What's the good thing, what's the bad thing about it? And very useful might be for people that wants to develop, what are the tools that you can use? So first of all, what are dedicated devices? And if you can Google, you'll see a lot of answers, but I like to reiterate what I think dedicated devices are. So, in my opinion, dedicated devices are just devices, hardware, with one purpose. You know, the phone used to be a dedicated device. You could make a phone call. It's not anymore, right? It's a tiny mini computer. You can run several types of software on apps. You can do all kinds of things. But the sport watch is a dedicated device, right? You cannot install, change software easily. It's just there for use support running. Navigation devices, camera, thermostat, media players, they all are dedicated devices. And why is it so interesting to work for dedicated devices? It's because in the near future, you will see more and more and more dedicated devices. Think about the thermostat. You know, the Nest, very popular. It's one of those devices that were not equipped with software not that long ago. But recently, we saw the added value of putting software on these devices and make it smart. And that will happen to more and more and more devices. Think of your microwave, think of your refrigerator. All devices very likely you now have just with a button on, off, temperature. But in the near future, 5 to 10 years, you already have them, but not really common. But more and more you will see these devices equipped with software. And it requires a different way of approaching of software development. It's a new challenges you have to face. So what are these challenges for when you develop software for dedicated devices? Well, first of all, the specifications of these devices are just enough to do the job. And let me explain that to you. So if you develop software on a mobile phone or a tablet or PC or servers, you know, these devices are quite well equipped with CPU power, memory. Of course, they have their limitations, but dedicated devices are just designed to just do the job. So they don't want to spend more on memory than really necessary. The reason, if you spend more on memory, if you have more memory, the device will be more expensive. If it's more expensive, they have to increase the price. If they have to increase the price, consumers might decide not to buy it. So it's always with the procurement department where they challenge you like, can't you do it just one CPU, slower CPU, less memory, less this? So it's really challenging to develop software on these devices. So also very often, there is specific hardware involved. It's not that it's a generic, you can use generic drivers. Very often requires you to do some investigation. How do you use this device? How do you use these components? The screen size, they all might be very specific for the type of solution you want to develop. Third of all, not less important, when you start to develop your application, very likely the device is not there ready for you. It's like the software in development. You cannot test your software on the device it should run on. Very often, in the very last moment, you will get the hardware really in the end situation where you can just test your software. Another thing is that it might be also applicable, of course, with a lot of other projects, but it involves a lot of teams. I'll give you an example. If the navigation device, as you buy it now in the shops, is quite a very mature software part. There's 100,000 lines of code. So we have like up to 40, 50 teams actually working together to create the software and all the stuff on the device. It's not like the first navigation devices where just a few, very handy guys were working and creating some code. It's really sophisticated. It's a lot of features in it, and a lot of teams are involved in developing. But most of all, developing dedicated devices comes with very strict deadlines. The deadline, the moment the hardware is ready, it's about to start production. It's about to start shipping the hardware. A delay of 2 months will cost you millions. So there is a deadline. And this is a bit in conflict with the agile way, like, well, we play around and priorities and change things. This is the hardware development is really waterfall. You cannot change that. So whenever you start a project, hardware and software, the hardware guys will follow a waterfall approach where they end up somewhere with a very strict deadline. I'll give you an example. Below you will see this software development project in an agile way. I'll discuss that later on in more detail. And the hardware is a bit more complex than here, but for the sake of explanation, it has a very clear waterfall approach where in the end they both get married and you start production. Missing that deadline is not an option. It's too expensive. So, we have Agile, Scrum, test development, extreme programming. What should I use? Well, I would just advise you use all of these methods if you like to use them. It's what is in the culture of your company, what works best for you. But if it's a more complex project, if it's more complex with involvement of a lot of teams, you should use one of the more mature frameworks of agile development. I just mentioned a few of you just to give some context. The first one is the DAD framework. It's the Disciplined Agile Delivery Framework. So this framework actually supports the size of multiple Scrum teams by defining each component to a Scrum team and very clear roles and responsibilities. So they are decentralized, organized, but with very strict roles, and you know exactly if I need to change something in this component, I have to talk to this person. And that person knows exactly, this is my responsibility, and this is what I'm supposed to do. So it's really organized around components, decentralized. Large-scale Scrum is completely the opposite. It's really centralized, organized. So they have one backlog with all the requirements, bunch of teams, and from a central point of view, actually, they will tell each individual team what to do and how to do, not how to do it, what to do, the priority, and what needs to be developed. It's very efficient, definitely if you're up to 5, 6, 7 Scrum teams, but they self will say also that more than 8 Scrum teams, it's hard to do it with this methodology. It's easy to do. You can easily, when you have some Scrum teams and you scale up to 4 or 5 Scrum teams to use it, but there is a limitation because you all organize it centrally. At TomTom, a few years ago, we started to use Scaled Agile Framework, or SAFe. And I want to go into a little bit deep how this framework can be used. So the idea of this framework, first of all, it's a free framework, so you can Google Scaled Agile Framework, you'll find a page, you can download all kind of information. And that's one of the things that is really nice about this. It also has a lot of training material, a lot of other organizations using it, so it's a really mature framework. But the nice thing about this is it has 3 different layers, actually. The first layer is the portfolio layer, where the business people actually tell the teams what, from a business point of view, is required. So they don't go into detail, they just say, well, this is a new product, this is a new, what they call epics. This is a new market we want to go into, like a truck product, or a bicycle product, or a motor bicycle product. And they will determine how much money will go into those products. They also define what they call, and this is important for later, the agile trains, agile release trains. So you define the trains, and train is nothing else than a bunch of teams actually that are responsible for one bundle of components or one product. So within TomTom you have to think of, we have a maps agile train, they deliver the maps. We have navigation software, they deliver all the navigation software. And you have what we call a consumer products agile train. That's where I work. They deliver the consumer products, and all those together end up in consumer products that we sell. The other program level is the level where actually someone is responsible for real delivering of software. So they get the priorities, and they will actually go into the more detailed phase where they talk about features, planning, and releases. And the lowest level is really detected from the complexity of all the other layers. It's the Scrum teams. So they're just focusing on this, doing the sprints, looking at the backlog. They work with like 5, 6, 7, 8 people together and deliver the software every 2 weeks in a sprint. So go back a bit more into the portfolio management, at the highest level. They're much concerned about strategy and funding. So you need to have some high level idea what you want to achieve in the longer term, right? So within TomTom, for instance, we work with like 2,000 to 3,000 engineers, and together, you need to have some central body that determines what to do in 2017, 2018. So they will define actually how much money will go into each release train, each market. They will tell what they want to achieve. Long-term planning. You have program management, it's the most operational way. They make decisions. So whether you use Agile or not, you will run into problems, right? So you will sometimes miss deadlines, have to make a decision, should I prioritize this above that? The business is involved in that. Very high level, just decide, go to the left, go to the right. Not how you do it, but just from a business point of view, this product has higher priority than the other product. And then you have governance. what are the rules? How do you want to interact with each other, the teams? But also, what is it, what the quality needs to be, what the product should look like, what is the market we go into. At the program level, as mentioned before, you have these release trains. Each program level is concerned with one release train, with 5 to 15 Scrum teams. And in the project, at this level, actually, you will see typical roles like a release manager. He's overall responsible for delivering of the software. The product manager, who is the contact person for the business. And the system team, the team that does the integration of all the Scrum teams, all the work, and actually do the end-to-end testing, does do the field testing, beta testing, make sure the product is ready to go out. And a typical release consists actually of 4 sprints. And in total we use 4 times 2 weeks. So the first 3 weeks, 3 sprints, so the first 6 weeks of each release, we will use for development of features. So we have a backlog, we plan, we design, we develop, and every 2 weeks we will deliver the software of that sprint. The last release, however, is what we call a HIP sprint. It's hardening, innovation, and planning. Every feature that doesn't make it after the 3 sprints is removed. It's not being part of the release. And this is the most difficult decision you have to make. Oh, it's just one more day, then I'll finish this feature. Yeah, right. Don't fall into that trap. The end date is after the 3 feature development sprints. Then you should start hardening. You should really start do the end-to-end testing, interoperability testing, everything you need to do to ensure the product is really ready to go out. You need to do some innovation. Think of new technologies, new libraries, new Android versions, all the stuff you need to do somewhere. You do that every end of the release. You spend time on that one. I do planning, preparation. There is a planning day, but before you can do that, actually you have to go into detail. Do I know the understanding, the requirements well? Is everything about UX known? Is everything designed well? You do that in the last sprint. And the program level has this typical planning day. The first start of the release, you start with a planning day. You will sit together with all the Scrum teams. So you hire a big room, come all together. You are prepared, so you have your estimations, you have your dependencies, and you make sure everything fits off. Just doesn't fit in the release, and you define this is the commitment for the release, this is what we will end up with. And then in the end, you have the demo day. You present your stakeholders that actually you did develop all the software that you intended to. And to give you an example, I mean, within TomTom, we will ship this software every 2 months. If you buy one of our products every 2 months, you can connect your device to the network, and we will send you updates with new features. So we really apply it. It's not just a 2 months nice thing, just demoing, the software is ready, and the software will be shipped. At the team level, it's different. You work together with a Scrum Master, product owner, and engineers. I think you're quite familiar with this one, so I will not go into too much depth. You have your team backlog. You plan a sprint of 2 weeks, you demo it. And most important, celebrations. You do that at the team level, right? You don't want to you want to have a party maybe with hundreds of people, but definitely the celebration, the achievements are at this level. So what works well with SAFe? First of all, it's the separation of these 3 levels. You really have different people looking at different angles to your products continuously. So each level, you will spend time at program level, product level, or at the team level. It's also extremely scalable. As mentioned before, we work with 50, 60 Scrum teams, and it all works well. You don't need to know the complexity of everything. You know, the team members only know they're responsible for that part, and that's what they can focus on. It does handle, and that's very important, not all the methodologies do that, it handles functional and non-functional requirements. So it's not just feature delivery, it's also performance improvements, security, using different frameworks, libraries. It's also part of, supported by this methodology. So what doesn't work well? Where do you run into problems? First of all, and I will go into more depth, it's project alignment, and I mean the alignment with the hardware products, the waterfall products, as mentioned before. It doesn't come with a solution for that. So we have to think about something to deal with this. Secondly, it's very much focused on efficiency. So with this amount of engineers, how can I produce most useful code? Which is great. But sometimes you need a little bit of predictability. You need to make sure that you will deliver this set of features in the end of a certain date. It assumes the methodology, it assumes that the capacity of the people is equally over time, which is not always the case. And it lacks risk management. So it doesn't talk anything about risks. And in most projects, at least we do, we have to face risks and have to deal with it. So first of all, project alignment. As mentioned before, the hardware guys, when they start, it's a train, it rolls, and it will deliver in the end some hardware. And we need to catch up, we need to align. Where are we still in line or not? So what we introduced is a few moments, it's a countdown, to make sure that we will end up in the end with software and the hardware. It starts with budgeting. So if they budget for some hardware developments, we make sure we have budget for software developments. And it looks obvious, but if you don't think about it, you know, it's a different department. They could start to think about new great products and don't consider any software development. Then you need to know the high-level planning. When do you ship? What is the feature set? Everything that comes with that. A T4 moment is what we call the end of the feasibility study. You tested everything. So you test hardware components, new modems, new Bluetooth stack, but you also tested the software. Bluetooth stack is software. Does it support that Bluetooth chip? Does the processor able to run the software that we want to run on top of it? So you do really physical tests. You might not have the hardware, but you can use referential hardware, right? So you might not have that typical box with the CPU and memory, but then use a tablet with that kind of CPU. Make sure you test something and check if it's possible to ship such kind of product with the software. And then the execution of a project, we have our moments where we check where are we, and in the end, do we deliver it? And you know, what is it that we deliver? So these moments we also see, and I don't discuss this in detail, in the waterfall approach. So the waterfall of hardware also mentions the T6, T5, T4, T2, and T2. I didn't mention T1 because within T1, it's also important, but not mentioned here, is actually depreciation of the product. So if the product goes out of sales anymore, out of the market, we, together with hardware guys, look into it, how we should do that, but that's not part of this presentation. Efficiency versus predictability. So in the good old days where we had waterfall approach for software development, we invest a lot in baselining, and you have different words for it, functional designs, blah, blah. But you did a lot of preparation, a lot of feasibility study, technical designs, architectural. Then you did some coding, and we had the implementation phase. So if you do purely the agile approach, you see you do as less as possible with baselining and feasibility study. And actually, you will have more dynamic way of software development, so you can adjust according to needs, because we all prove that whatever we try to predict here, what we needed, during the time we start executing, we changed our mind. That's why we introduced this, right? I would say when you start developing software for dedicated devices and embedded devices, you have to do a bit more feasibility study. It's unavoidable if you want to be successful. It's because you have the limited scope of the limited capacity of the hardware. It's because of the deadlines you have to fix. You need to do a bit more in feasibility of the project. So, give you an example what we try to do, which is a little bit not in line with purely agile development. First of all, with agile, you have portfolio management, long-term planning, very high level. Then at the lower level of features, you're only interested in the next 2 months, the release. So you have a planning day of that release, you think of that, what can I ship then? And that's the detail planning that you do. You don't think of this release after that or the release after that. The good thing about it, it's really focused, you know what to think about, it's not confusing a lot. The problem is if you do a big project where you need a couple of releases to get the whole product in the market, you will have dependencies. You will have a map is needed for traffic, traffic's needed for the routing engine, just as an example. Platform is needed for the task manager. So you have dependencies for developing one part of it, depending on the other part. So there's a logical sequence in it. You also have really required components and what we call nice to have, which we could ship later. If you don't do anything with this, you could end up planning with this. So you have 4 releases. You start with platform here. Here you go with a map, task manager, traffic, and you need 4 releases to get all the required blue components out of the market. Why does this happen? Because you start thinking about the first release, then you start thinking about the second release, and you didn't, in the beginning, think of the whole complexity, what you needed to achieve. If you do that, you could plan differently, right? So you start with the most lengthy plan. So you start with map, traffic, routing, and in the end of the third release, actually, you could ship the product. It saves 1 release to release a product, which again saves you quite a few dollars in the end. One of the other assumptions of SAFe is that the capacity is stable, the need for capacity, availability of capacity. And that might be right in a lot of situations, but if you want to deliver something in the end of the deadline, you will not envision this situation. And as we call it, it's BS. And this is the English words for bullshit, right? I wish this was the case. Unfortunately, it's not. Oh, it's very likely like this. You start something, you have a moment which lower, more requirements and less, again, in the end, and all variations in between. So how to deal with that? Well, first of all, very often this happens because you need a specific expertise. So you want to have that all the engineers could do everything, but you have experts on audio, on connectivity, on platform, Android specific knowledge. And not always those are available all the time, or the need for these people are the same at all the time. So what we have is a kind of specialist team that will fly over all these different teams and assist there where necessary. It's a way to deal with these difference in demand of capacity. And we also hire contractors. You know, every planning before next release, we look into it, do we have enough capacity? If not, we will ask our friends to assist us, pay them a few euros or zloty, and they will help us to get the job done. Very efficient, but you need to do it. Don't assume you don't need to do it, because you will run into a problem. Another thing that's missing is risk management. And I like this definition a lot. It's the intention interaction with uncertainty, and that's what it is. You know, if something bad happens, I know for sure it will happen, it's not a risk. It's not nice, but it will happen to you. So to try to avoid the uncertainty is, first of all, identify it. Spend some time. This is why you need more time in the feasibility study. Sit down with the architect. What is the risk? What are the items that we could lose on? A different Bluetooth stack. Are we sure we can deploy Android using that Bluetooth stack? Don't know. Okay, that's a risk, right? If you don't know, it's a risk. You should identify ways. You should identify those and try to reduce the impact if something happens. Secondly, plan these risky activities in the first release. So I know, maybe it's different in your organization, but my team very often like to focus on the nice features, no? Nice UIs, nice animations. They want to show off. They want to develop something and go to you like, look, it's very nice. But this driver for the modem might be more riskful, right? But it's not sexy to show you. It's nothing to show at all. It's the device driver, right? But it's important to start with those risky components, because they fail, you will not have a product in the end. UI most often is not risky, it's just work. So, okay, we talked about Agile, I talked about what can SAFe do, what can't it do, and now we look a little bit more depth in the tools. So what are the tools available in the market that could help you doing this? So I discussed a few of these tools. We use many more, but I thought these are worthwhile mentioning. So first of all, Rally. Does anyone knows about Rally? Is anyone using Rally? Okay, a few of you. Okay, so that's still worth discussing it. So Rally is a quite expensive tool, I must say, to use, but it's worth doing so. So Rally is a tool that actually manages all your requirements. It can do and progress. It's really supporting the structure that you need when you work with a lot of teams. So it supports the theme, the budgeting level, goes into the epics. Epics are broken down into features. Features are broken down into user stories. User stories broken down in tasks. And you can measure progress. You can manage your acceptance criteria for all of these different levels. And that is actually the hierarchy that you need. It rolls up, and you know exactly for this release of this epic, you know, this is the progress, and you know your status. Very important. So this is a few of the repos you can get out of Rally. It's one of all is what I liked is the cockpit. You know, the overall overview of the features. Where are we? How is the progress? 100% good. 0% progress. I should have a word with these teams. You can look into it all the time. It's up to date. Everyone's using it. You immediately see what the status is. At the sprint level, so this is at a higher level, release level. This is at the sprint level. You see not a burn down, a burn up. So you see the progress, how much features are defined, in progress, blue is completed, and green accepted. So when I saw this example, I just checked yesterday the slides, and I thought, why would they start with 25 story points and end up with 50? I think it's in one sprint, so they did something wrong when they started the sprint, right? You should know at least what to do in the beginning. So somewhere after a few days, we've got these user stories. The good news is actually that they could actually deliver all the user stories, so that's basically the good news. But it's a funny slide. Another thing which is quite important is to see the velocity over time per sprint. What did they plan and what did they deliver? And that's not used to point fingers like, hey, you're a performing team, you're not a performing team. It's to learn. It's if a team didn't deliver anything, you should know and you should talk to the team. You should not just, use these reports if you don't take actions. You should only use these reports if you really use them and go then to talk to these teams. Why does one sprint work well and one sprint doesn't provide you everything? It could be for reasons you're not, you cannot change anything about, but it could be for reasons, you already knew or you can do something about. And to give you an example, we had a few weeks ago, we had in Amsterdam one big day, the productivity in the whole building was about 0. That day, no one did do anything. It's every 5 years we have the sale. The sale is a big event, so ships of these size will come to Amsterdam, and actually this is the view from our office. So I cannot blame the people that I looked outside the whole day looking at all these big sail ships. But that's one day of every 5 years, so that doesn't hurt too much. But if it's more often that you see complete failure of a sprint, you should talk to the teams to see what's happening. That was Rally. Jira. Anyone using Jira? Okay, skip that one. No. So Jira, I think, is one of the most favorite tools that users of the developers use. I use it for ages, and it's really easy to use. It's fast if you deploy it well, and we use a few plugins with that. It's Greenhopper. I'm not sure if you use it, but it's really the replacement of the stickies on the board. Some teams use the stickies, they like it, and some use a big screen with Greenhopper where they can move user stories from to do, to progress, the status change that for the daily stand-ups. And we also use Tempo. I'm not sure if you're aware of that. We started to use it 2 years ago. It's a time registration tool. Okay, some of you already like, ooh, time registration. Well, except that sometimes the government is requiring it, at least in the Netherlands. It's also useful sometimes if you just plan for something to look afterwards, what we actually spent? Is there a big delta in it? And what went wrong with the estimations? So I would say use time registration in one way. And Tempus really makes it easy. You open user story, when you close it, system asks, how much time did you spend? 8 hours. Okay. You know, it's not a separate tool, it's really integrated into Jira. Confluence, SharePoint, anyone? A few? So, 2 different systems we use for documentations. One of them is the Confluence. Confluence is the wiki pages, right? So it's really a collaboration tool. Engineers love it, I love it. It's easy to use, and you really can build nice screens, nice integration with other tools. You can have Jira reports in it. You can link to Rally reports. So you can create overviews. It's really easy to share information. But sometimes you need something different. SharePoint in this case. We use it for the more formal documents. You know, it's easy to use all the traditional Word documents, PowerPoints. But it comes with very strong versioning, very strong authorization. So some documents, budget reports, and reports of a sprint, they little need some more of guidance. You cannot just share that on a wiki page, everyone can change it. No, it needs a version, it needs some authority that people approve it before you know for sure this is the version that I can distribute to the higher management. Next to that, we use RunnerX. RunnerX is a tool for testing. And if something is important, well, a lot of things are important, but definitely important is automated testing. If you want to be really agile, you need to set up something for automated testing. RunnerX is a tool that we use for very many different tests. It ensures that every change we make is actually tested in all these different areas. And to give you some examples, one of the tests that we do every time again is the Bluetooth interoperability test. So the TomTom navigation devices, for instance, they can connect with a lot of Bluetooth phones. And they all come with some flavors, different Bluetooth technology. And you need to make sure that if you ship every 2 months new software, the devices still work with the phones that you support. We deploy a lot of new maps. Easy to say, you have to check for sure that these maps also run on your device. We have mobile applications that work together with the devices. We have speech recognition tests that we automate. So we support speech recognition, so we have a small studio actually with some animation, a computer that every time repeats like start navigation, louder, harder, you know, check if the speech in different languages is still recognized by the system. Shop demos in different languages. Smoke tests. Every moment you deploy code, if you commit code to the system, we perform smoke tests to see if the majority functionality still is working correctly. So it's a system actually that can handle all kind of tests automatically, and ensures you that the software you're developing is at the level it needs to be. Then the last tool, Tiobe. I don't think many people heard about it. Is anyone? No one. Great, I can spend some time here. No. So Tiobe, I think whether you use Tiobe or any other system, it's important to measure the quality of your code. It's to avoid to have technical debt in the end. And technical debt is something like, shit will happen, you just don't know when. And you don't want that in your projects. So it does look into different technical areas to check if your code is at a certain level. First of all, it does check code coverage, but also does the abstract interpretation. Like, if you do open a database connection, do you close it somewhere? Or is it possible that you, somewhere in the loop, will exit from there and you missed it close? It's detecting very often memory leaks. You know, all kind of checks whether you properly code your software. It's also do some calculation on the cyclomatic complexity. You know, you can sometimes you see code with if, then, and while constructions like 14 levels deep. No one knows in the middle somewhere what will happen there. You know, you should reduce that. This is just an indicator where you could look at it to simplify it a bit. Do you apply, does that have compiler warnings? I hope everyone here knows not to have compiler warnings. It's a warning after all, so avoid it. Coding standards, whatever is applicable in your organization, make sure it's tested against it. I mean, there's nothing wrong with have nothing more wrong, I would say, to have coding standards somewhere. You know, very often, very large organizations, someone is responsible for coding standards, and they write these nice reports, and they have the author somewhere in some attic. They use these big reports. This is how people should code, but no one's checking against it. Make sure you check your code against it. Otherwise, no use of having coding standards. Code duplications, copy a class, change 2 lines. It works. Don't do that. Fan out code, that code, all things you need to avoid. And in the end, what you see, your code will be measured. And after these TOBIT tests, actually, you will get a score. And we at TomTom, we want to have a B, at least, quality of all the code. A will be optimal. Some components are A, but we don't accept code below that. We know for sure something will happen very soon which you don't like. So make sure your code is at a good quality. So that's it. Any questions? Someone told me this is questions, so I hope this is right. Not? Ah. Yeah, so I think if you, I don't think, so implementing a method like that, first of all, starts with a moment of looking into the various different methodologies, and some small part of the organization implemented there, see what the benefits are, and does it fit, does it work, and if it doesn't fit, can you adjust it accordingly? So in TomTom, actually, it took a year to really do it, but we trained all the people. All the people are certified, no one exception. Every new recruited people will go to that training. We have what we call our experts. So some of the product owners, some of the Scrum Masters are really experts. So they are the real representatives. So they have more training, and they could actually help other people to make sure it's applied well. So this was a really, from higher management, a decision to do it. The reason was obvious. TomTom grew over the last 10 years extremely fast. So when it launched the first device, we were with 50 people, now 4,500. So if you grow that fast, it starts becoming blurry a little bit. And then it was time to have a structured way of doing software development. And we decided to use SAFe. And actually, afterwards, we can definitely tell it's really great framework to use. So above a year, almost. Sorry?
Oh. You said that at the planning day you gather all the teams in one room. So only the leaders or everyone?
That's an important question. So what will happen in the beginning when you start SAFe? Everyone is joining. It's free lunch after all, and very often pizza afterwards. So you're there with hundreds of people, or 150 people, because it's per release train, right? So I don't invite the whole TomTom. It's per release train. So in my situation, it's like 10, 11 teams. But still, there's a lot of people. Afterwards, definitely mandatory is the Scrum Master and a product owner. And sometimes an expert of the engineers, the one who knows basically everything what happens in the team. That are really mandatory. Others are free. The good thing is, next to using it for planning, it's also the involvement of the people to get commitments for delivery, right? People should believe in the story. So the planning day is not just planning, it's also the product manager comes there explaining why is this important. If we produce this new product, what's the market, what's the value, They should believe in the story, that helps. So I would invite everyone.
So it's quite a lot of people, and I used to work in one team with 7 people, and it sometimes takes us more than half a day to plan next sprint. So do you have any tips how to manage such a crowd to produce something useful?
Yes. Yes, so that's the exact same learning I have. You have to invite everyone, and in the end of the day, you didn't decide anything. So that's what we call preparation. So we have preparation with smaller teams of people where we do the estimations already, the dependencies, the risks. We know all of that before we start into the planning day. So the planning day is really check, 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 and not discussing like, what do we want to achieve here? How much time would it need? That's way too much work with all these people involved. And you could do in smaller teams. Yes?
I would like to ask you about the Analytics tool.
Yes?
Why did you choose it? And have you thought about any test automation tool like Xamarin, for example?
Yes, so I think this is our fourth one. I wasn't involved in the evaluation, but it's more over time. So I'm not saying you should use this one. I just say this is the one we use at the moment, and we're very happy with. So we used, and I don't know all the systems we used before, other tools, but we ended up with some area we couldn't support with the current system. And Ranorex at the moment does do support for all these different variations of tests. So we did use other testing tools, and there are very good one others outside too, and probably cheaper ones because this is quite expensive. So yeah, just use one that you know, but at least use one.
Okay, I would like to ask about the maintenance process, how it fits with SAFe. I mean, I can imagine that you have 2 months release, but there might be a need for a hotfix or something like that. How you deal with that?
Yes. So at this moment, the build system to create the software is all scripted by our engineers. It's just not the nicest way to do it, but it's the situation. We will move to more mature systems, but we have always the latest version of the software available, of course, in our source code management system, Git at the moment we're using. We used to use Perforce before, at the moment we're moving to Git. And we are able to deploy hotfixes within 48 hours. That happens. So it's quite a complex area where you ship your products in areas like, for instance, the UK is very specific. The UK has Vodafone with, it becomes a bit technical. Keep it simple. It's a different GPS system than elsewhere in Europe. And we had a problem with our connected devices. It failed. We shipped the product, it failed. And then you need to be able to update it within 48 hours. And that's what we're able to, yes. The system teams. Yes, so you have the feature teams, that's the teams level. At the program level, we have what we call system teams. It's the product manager, it's the release manager, but also the continuous integration experts, the test experts, and they are able to get the latest fix, integrate it, and ship it within 48 hours. It's a special team indeed, nothing doing anything else than just releasing software. But that includes all the testing, right? So it's not like big fixing the bug and hope it works. It requires you to go over all the tests.
Are you using,
Sure.
are you using kind of manual testers or only automated tests because of the,
Yeah, it's at the moment still we use manual tests. We do that in India. And next to this really manual test, I consider field testing also manual. So whatever you can automate, it's different in a laboratory than it is in the field. So we have people that just go in the car, driving with it.
because if you receive a hardware which is ready to be shipped, you don't have the time for manual testing, right?
Not much, no. So that's the challenging part. Although we have quite a few manual testers, so we could do tests in parallel. We do manual testing, but you need to reduce that in order to ship early. Yeah.
Do we have more questions?
Thank you. But one more question. So.
I'm wondering, you mentioned that every 4th sprint is the 6th sprint.
Yes.
The 6th sprint where you do the planning of the whole release, and the preparation already has the estimations from the teams. Actually.
Yeah. So the
So how it works? I mean, does actually teams are doing some drawings and estimations beforehand?
Yeah.
And knowing and committing on every sprint.
they don't commit.
They're like a scale.
So in the HIP sprint is hardening innovation and planning. So it's hardening, bug fixing, that all comes out manual testing, field test and everything. So that's quite some part of the work. Innovations, of course, is like 10-20%. And planning is all the individual teams, they know the user stories, or they break down features into user stories and do planning and dependency. What do you need to start with this up front? They don't know the whole picture yet. So it's not commitment to a sprint or to a release. That's done in the planning day. But when you start with the planning day, you don't have to discuss like how much time would it need to implement this. It's that you already know.
I was wondering how often it might happen that actual commitment during the sprint is off with what they said during the planning day.
It happens. It happens a lot, yes. You try to reduce that though. So what my target is 80% of the commitment is delivered. That's the target. If it's more than 90%, you didn't plan enough. It's lower than 70%, you're not planned well. So 80% is the target. Any more? Okay. Thank you.